So our next speaker is Eric Floehr, talking about art and science with 6 million time-lapse images and Python. Eric is a local Pythonista. He was the chair of PyOhio for multiple years, is still responsible for our sponsorship. He is tall, has his own Python business, and is an awesome human being.
All right, thank you, Jason. So today I want to talk to you about making art and doing science with 6 million time-lapse images and Python, of course. So if anyone wants to look at my code, there's where you can find it. So everything that you see on the slides is going to be available there. I will give you fair warning, the code is evolving. It's in the middle of a bunch of refactorings. So if you have any questions about it or whatever, just feel free to email me. So I had an idea to put a camera, point it out at the western sky in my house, and start taking pictures. That is a Canon A510 digital camera that I had laying around. I put it on a tripod, connected it to a Raspberry Pi, and with Gphoto 2, you can set it up to take an image every number of seconds that you want. So with the Raspberry Pi, it's controlling the Canon A510 digital camera. It's pulling an image off the camera every 10 seconds and then pushing it to a network-attached storage device that I have in my house that's rated and has about 12 terabytes of storage. So to start out, I'd like to look at a few images that my time-lapse camera has taken. It gets to take really beautiful sunsets because it's pointing at the western sky. This one was really serendipitously captured. I just happened to be looking at an image, and I saw that there were 3 birds, probably doves, circled around the sun, one with its wings down, one with its wings up, and one with its wings kind of centered. And it floored me. So I actually made a printout of that and framed it and gave it to my mom. This is a cold air funnel. So it's not a tornado, but if you can see the little cloud that's coming down, there was actually rotation, and it lasted for about 10 minutes. And it's something, unless you were actually looking up at the sky, I mean, there's no warnings or anything. It's just a little bit of rotation that looks kind of like a tornado, but it's not. I also happen to capture lightning a lot. You'd think that'd be really surprising because it's only taking an image every 10 seconds. So it just has to capture the lightning at just the right time. So this happened at night, and I thought it was really cool the way it illuminated the cloud. This here, I don't know how well you can see it here, but there's basically a shelf cloud, and it's very smooth. This image here is actually lit only by lightning. This happened in the middle of the night. So imagine just sitting out on your porch, and it's a dark sky, and all of a sudden it lights up, and you see this big, huge cloud coming towards you. Here's what it looks like in the daytime. This was another thunderstorm and another shelf cloud that came through, and we're going to actually look at a video of this later because it's really cool. So I'm on my 3rd version of this. I actually started out with a webcam, 640 by 480. I just wasn't using it for anything. I put it in a window. The 2nd version, I had a grand idea of having a whole bunch of cameras in like a 360-degree view and all that, and my eyes were a little too big for my stomach, so I went back to 1 camera. There's a number of things I learned from doing this. One thing is that SD cards are not reliable, and that's both on the camera and on the Raspberry Pi, so I keep everything in RAM. For those of you that have digital cameras, which is probably everyone now, the SD card, if you run it a number of times, if you put images on a number of times, it'll eventually wear out and it won't be reliable. So actually, Gphoto 2 gives you the ability to pull the image directly from the memory of the camera, and then I store it in a TempFS on the Raspberry Pi, so it stays in RAM on the Raspberry Pi, and then from there it goes to the NAS, which is rated storage. But that's the first time it actually hits disk. So I started this version, 3rd version, in July of 2013. Now I have over 6.5 million images, which equates to 20 trillion pixels. And right now I'm using approximately 4.2 terabytes of storage. Actually, I have a workstation, and I can only put 2 drives in it, so I don't have it rated or anything. I never thought I would ever say that I had to replace a 4 terabyte hard drive with a 6 terabyte hard drive. So I'm on my 3rd camera. Cameras actually wear out. Because it's pointing at the sun, the CCD eventually kind of goes funky. So the first camera lasted 319 days. The second one lasted a little less, and now I'm on my 3rd one. And actually, just recently, the Raspberry Pi died on me. I don't know what happened, but something went funky on it, and it started rebooting itself. So anyway, 4.2 terabytes is a lot of data. So we need a way to organize that data. And when you organize data, what do you think? Database. Yes, thanks. So I store the image data, not the images themselves, but I store the data on the images in Postgres. And you need to know, usually, if you're going to use Python, you need an ORM. There's 2 major choices, SQL Alchemy and Django ORM. Well, SQL, they're both great, but I'm very familiar with the Django ORM, so I actually just use the Django ORM without a website, just the ORM, in the back end to load up the data and do manipulation. And in addition to just pulling the file information off, I also get a bunch of information about the image itself through the EXIF data using PyEXIF, and about the image itself through Pillow. So here's the image model. I don't want to spend a whole lot of time on the code, but with Django ORM, for those who are not familiar, you explicitly define in a model the columns in your table. And so here's some just basic file info, the path, where the file is located, the name of the file, how big it is, and when the photo was taken. And then I get some of the EXIF info, like the f-stop, the exposure, because I don't control for that. I let the camera decide how long of an exposure and what f-stop. The only thing that I control is I set focus to infinity, because when you're capturing the sky, you're not focusing on anything close. And then I pick a little bit of additional info using Pillow, the center color, the average color, the standard deviation of the RG and B. And one important thing is I set the ordering on timestamps. So whenever I create a query using the Django ORM, I set it to order by timestamp, because in general, you're going to want increasing time. It's very rare that you're going to want time to run backwards. All right, so here's the actual code to read an image and pull the EXIF data. I mean, it's really not a lot of code. Get the name of the file, and then also get some of the statistics on the image using Pillow. So using the imagestat.stat and getting some of the extrema, including the max color, the min color, the mean color, and then also the middle color. So now that we have this data in a database, let's explore it. So using just simple SQL queries, these images come to me in JPEG. The camera itself it was just a camera I had laying around. It was actually the first digital camera we ever owned. So I don't get raw images. I get JPEG images. Well, JPEG is a compressed image format. So if you have an image that is larger in size, that means it's less compressible. And if it's less compressible, that means there's a lot of interesting things happening. So this is a query to find the largest JPEG image in my database. And you can see there's a lot of complexity in that image. So it wasn't compressed, you couldn't compress it enough, or as much as normal. So you could also look at standard deviation. So this is the image that has the most standard deviation. And you can see in the top left it's black, in the kind of the middle right it's very white. So you can see the difference in color there. So the next thing I had to do is, once the images were in, I wanted to smooth out those images. While I take an image every 10 seconds, Sometimes it's actually 9 seconds, sometimes it's 11, sometimes it's 12. You know, because of the way the camera actually takes the image, sometimes it takes a moment to find its exposure and all that. So it kind of goes back and forth. So I have to normalize it. Because in an ideal case, I take an image every 10 seconds, I want to kind of align each image to a 10-second boundary, and that's called normalization. In addition, it allows for gaps in the data. If I want to make a video of a day, and say for whatever reason I have a gap of a minute or two, I don't want to just jump all of a sudden from, say 1 o'clock to 1:10, because that would mess up, the smooth flow of time. So if I have a normal for that gap, I can put a blank image, I could say no data, I could do all kinds of things with that gap, but I still know that that gap was some amount of time. So the normalization process, I started out with a really complex normalization process, and it kind of was not working real well. So worked out with a friend that if you just start with the first image and you make it as close as possible to that 10-second boundary, and then you just keep filling in the slots until you get to a point where you're above that 10-second gap, it works out really well. And it prevents the problem that I had with the first version, which was a flapping problem. So if you say, okay, I want to normalize, just find me the closest one. What happens is, like say if we do it every 10 seconds, so 0 and 10, if we have an image that's taken on 4 seconds, it's going to go to the lower one. And then the next one is maybe 12 seconds, and it's a 6, and it's going to go to the upper one. So then you have a gap of 10 seconds. Whereas really what I want to do is I just want to say, okay, this is the next image. Even though it's 12 seconds different, I want to put it in the next slot, and this normalization formula solves that problem. So the normalized model is actually just 2 rows, or 2 columns. The timestamp, the normal timestamp, and a pointer to the actual image information. And one thing I just wanted to point out is there's actually a difference in rounding between Python 2 and Python 3, and it really caught me by surprise. So Python 2, when you use round, and say I'm rounding on like a 0.5, 0.5 will always, in Python 2, will always round up, I believe. It's either up or down, but always. Python 3, it actually rounds even odd. So 2.5 rounds to 2, and 3.5 rounds to 4. And it actually does that because it's a better rounding algorithm. But it was something that you just don't think about. So I basically implemented my own rounding to make sure it works in both 2 and 3. All right, so take a quick moment to look at the normals, how I create them. But actually, I'm going to skip most of this. But it's basically, this is the code that implements the algorithm that I just mentioned to you. So the next thing we need to do is we need to make movies, right? Now that we have a bunch of images and normal images, we can make movies with it, right? Because movies is just frame, 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 frame. Now, Python doesn't have a real nice way to make movies, at least not that I'm aware of. So I basically just shell out to a program called mencoder. And what mencoder can do is take a list of images and take that list and turn it into a movie. And I call mencoder using the subprocess library that's built into Python. Subprocess call will run it and just return. Subprocess check call, if mencoder returns with an error, it will turn that error into a Python exception. So I know within my code whether or not mencoder worked or not. So I'm going to show you the first video, which is the thunderstorm video I had mentioned before. So Here we go. So you'll watch the storm come in. And you can really, when the atmosphere is speeded up, you can really see the dynamic nature and it almost looks like water, right? It looks like you're looking up from underwater at a big wave that just comes through. And that was from a thunderstorm. So that was at 10 seconds per frame and 24 frames a second. So it's 240 seconds per second of video. So if we look at all the images that I've taken, which is 6 million images, and so that's 65 million seconds, so 6.5 million times 10, 1.1 million minutes, 18,000 hours, it's 755 days of real time so far. So if we turn that into a movie at 24 frames a second, then if we use all the frames, that movie would be over 3 days long. So if we take 1 hour of that movie, that 1 hour of the movie is 10 days of real time at 24 images per second. 10 days is like an eternity to my teenage daughters. So therefore, we have an eternity in an hour. All right. So it's fine to do movies of an hour or a day or whatever, but we want to make movies and do things in context. And one of the big context clues that we have is sunrise and sunset, because that separates day from night. And if we can separate day from night, we can do some really interesting things with that. So there's a library created by Brandon Rhodes called Pyephem, and it allows you to get the sunset, sunrise, moonset, moonrise, and a lot of other cool things about the sky. So this function, it's just a 2-line function. Given an observer, tell me when the next sunset is going to be. All right? So that's all that does. And it just makes it convenient, so you don't have to turn it into UTC time zone and stuff like that. So then I take that function, sunset function, and create a generator from it. So that generator will just give me consecutive sunsets. And for convenience, which I'll explain later, I can offset that by some number of minutes or hours. So if I want to say, give me all the times 50 minutes before sunset. So the sun is like up in the sky. And I say, okay, give me the next day, 50 minutes before sunset. Now I can make things synchronized to the sun. So there's where that is. And it's just using yield. So I basically, every day, I increment a day, get the next sunset, and add the offset. Get the next day, get the next sunset with the offset. So with that, now I can say, give me 50 minutes before sunrise, or before sunset, and I can do that for each day and see the progression of time. One of the interesting things that I just didn't really have a whole lot of conception about, I just didn't even think about it, was that the sun changes its position in the sky over a course of a year. It goes from the maximum extent at the summer solstice and the winter solstice at its minimum extent. So these are 2 images, and you can see the minimum and maximum extent of the sun 50 minutes before sunset. And we can turn that into a video. And let's close this out. And I darkened up the image so that you can actually see the sun, because there's a number of cloudy days, but you can actually see the sun moving. North would be to the right. So since I'm facing west, south would be to the left. So you can see the sun just kind of every day moving further and further north, or south. So this video here is synchronized to 50 minutes before sunrise, or before sunset. Further south. Further south in the winter. For sunset, yes. For sunset, and further north in the summer. Because it kind of goes like this. It's higher in the sky, so it kind of brings it north. Because of the tilt of the earth, right? You know? All right. So while we've kind of lost some of that observational knowledge of the sky, this is something that was very, very important to the Native Americans, the Mayans, you know, in earlier cultures, because they didn't have, you know, iWatches and, you know, cell phones and things like that. They always knew what time it was. So the top image there is of a Mayan pyramid, and at the summer, I believe it's actually the spring equinox. I'm not sure of this. One of the important times, either the equinox or the solstice, the shadow of the stepped pyramid projects on the steps. And if you can see on the left-hand side there, you can see the wavy pattern. That is a snake. And in fact, at the base of the steps, if you can see that little thing jutting out like this, it's the head of a snake. I had to have that reference because it's Python, right? So at a significant point in the year, you now have this representation of a snake in the Mayan pyramid. And then the one on the bottom is at Chaco Canyon. There's concentric circles, and there's a slit in the rock. And at a specific, you know, again, at probably the summer solstice, the slit aligns perfectly with the center of the concentric circles. And how far away from that center it gets in each concentric circle, they can tell them how far away they are from that point. So actually, this is a calendar. Those concentric circles are a calendar. All right. So now that we have the data organized, we need to reduce our workload, because I don't know about you, but I can't look at all these images. Even if I looked at one image per second, it would take me 2.5 hours every single day to review the previous day's images. Now, we can throw out mostly half of them because they're dark, right? It's nighttime, but sometimes interesting things happen in the night too, so I don't want to miss any of those either. So how am I going to reduce my workload? Well, one of the things I discovered is that, especially since I'm interested in UFOs and whatnot, at night, what are the interesting things, right? They're not the things that are dark, they're the things that are light, right? The moon, Jupiter, helicopters, UFOs. So I borrowed something that's used in astronomy a lot, and it's called stacking, image stacking. In astronomy, image stacking is often used to take a number of different images to sharpen, to create an image that is sharper than any one image of itself. But what I do is I use Pillow. There is a function called lighter, which takes two images and creates a third image that has the lightest pixel from each of those two images. And so if I stack all the images from nighttime, then it will give me, every pixel will have the lightest pixel, the brightest pixel, so I can see if there's anything interesting happening that night. Now, during the day, it's just the opposite, right? During the day, often the things that are the most interesting are the things that are darker than the background. So, in order to do that stacking, I get the sunset and I get the sunrise, but because of dusk, right, you know, it's not completely dark yet, and it's not completely light, or it's not completely dark at sunrise and sunset. I basically say, I want an hour after sunset, an hour before sunrise, and stack every single image from that. And there's my Django ORM call to get those images. And then I call ImageChops lighter, which gets me the lighter of two images, and I just iterate over all the images and then I can also invert that, because at night you're going to have this dark image with little white pixels, and it's actually easier for the eye to see mostly white with dark images or dark things that are interesting. So when I do that, I get really cool stuff. So this was a thunderstorm that happened overnight.
That's several images.
Yes, actually that is actually mostly one image, actually. I think there's a little bit of lightning that's from a different image, but the big bolt that kind of goes off to the left was one image. So here's a negative image, right? You might not have noticed too much if it was dark, but actually in the right-hand corner, you see those little speckles. I zoom those up. It's actually, I don't know if they were insects or birds. I'm still trying to figure that out, but they were illuminated by a street lamp that sits on the street off the image, and it's the only time I've ever captured that. And I have no idea what it is. I don't know if it was like cicadas, something that was very reflective. But then here's some more, it could be UFOs, aliens. So here's some more lightning. Now this is really cool because it's a whole bunch of different images. So that is helicopter, a lot of lightning pictures, and also the moon, and I believe Venus and Jupiter are the two big streaks that you see.
This is a few hundred.
This is one night. One night.
Those lines, that's a star track or a planet
Correct.
track.
Correct. Yep. So I would have liked to have thought that those were UFOs, but those are not. The big streak on the left is the moon, and the streak on the right, or the dashes on the right, is a medical helicopter. There's actually a medical helicopter base a couple miles to the west of where my house is. So you'll often see, the helicopter. Now, on winter nights, when there's very little humidity, you can get a lot of planes, you can get a lot of star trails. And in fact, I don't know how well you can see it, but there's a big streak to the left, in the left corner, that's very blue. And I think that is Sirius, the dog star. So here you can actually see, there's actually, if you look really closely and have a good monitor, you can see about 20-some star trails. So, as I mentioned before, you can actually do the same thing on the day side, only using the darkest pixel. So that's one day of birds. Alfred Hitchcock would make a movie out of this. So it's not always that awesome, but
How many birds were there actually?
yeah. So there was actually a flock. If you look at it, there was actually a couple of flocks, and they kind of circled around. So we also capture balloons.
Cool.
And oh my God, that scared the crap out of me. And it's not me because he has biceps. Yeah. So yeah, guy came to power wash our house. All right. So we can also make some really cool art with just taking the lightest pixel in an image during the day. So those are planes, the sun, and you can kind of get some neat little streaks of clouds. So now that we have, a way to make these images, we don't want to manually have to create them every day. We want to create an infrastructure that just runs things. And because it's CPU intensive, we want to make sure that we can make use of the awesome computing power that's available to us today through multiple cores, multiple machines, and everything. So in order to do that, there is a task framework called Celery for Python, and it integrates with Django. So basically, all you have to do to create asynchronous tasks which run Python methods is just decorate a method in a file called task.py in your Django app, and you run Django Celery, and now all of a sudden, if you call tasks.insert.delay, now all of a sudden you have a asynchronous task framework with just a few lines of code. So now that we have a task infrastructure and we can run things on multiple cores and multiple machines if we want to, let's look at some science and see some art. Because one of the things that I've always thought is that science can be beautiful and art can teach. But it's not all about looking beautiful. You got to make some money. So I've collected the 6 million images. We're going to make art and do science. I need your help with phase 3. But I know that phase 4 is going to be profit. I know it. So the first thing we're going to do is we're going to actually visualize a day in a single image. Right? We've looked at stacking, but this is a different way to look at images and kind of visualize an entire day at once. So what if we had a scanner and we took one single line in an image and then we just stacked them this way? So on the right, the image, the top of the image is midnight, and then it goes through the day, and then the bottom of the image is midnight of the next day. So that's an entire day. You can see at the bottom there's a sun crossing. So how are we going to do that in Python? Well, we're going to use our Django RM and get a day's worth of images. And then we're going to iterate through those. And we use the enumerate function that's built into Python to get a count of each row. So, the first image at midnight's row 1, then row 2, then row 3, all the way to 8,640 images in one day. And then this is where we use Pillow to crop that single row in the image and then paste it to the new image that I'm constructing. And this is what it looks like. Like I said before, you had midnight to midnight, but you can see where sunrise is, you can see where sunset is, you can see cloudy versus less cloudy, you can see moon crossings and sun crossings. But here's some science you can do with that pretty image. You can really illustrate the difference in day length between the shortest day of the year and the longest day of the year. You can really see why people get the winter blues. There's a lot more black in that image on the left than there is on the right. You can also compare images on each, it's the same day through many years. You can see that 2015 actually was probably the least cloudy July 20th of any of them. So you can also scan vertically instead of just horizontally. So basically, instead of the top of the image and scanning horizontally, we're scanning vertically. So we get that the same way, only we crop a column instead of a row. And it looks something like this. Now the really cool thing with this is with our movies so far, time has kind of been on the z-axis, right? Each frame of an image or of a movie is a different point in time. But what if we put time on the x-axis? We're going to look at that movie here. So as time is progressing, so that's sunrise, and sunrise, so it's basically scanning the sunrise image and moving it, as we go. So time is advancing on the x-axis here. So you can actually see the clouds moving, but they move in a different way. It's really kind of fascinating. I mean, I think. Yeah. So
the UFOs told you about this.
Yeah, what is? I'm not even sure what that is. I'm really not. It might actually be a UFO. So, and then now we're heading towards. Actually, there was some rain here. See where it's dark? It kind of got rainy, and you'll actually see, if you look closely, you'll see little raindrops that hit the window. See on the left or on the right there. and then it got lighter, and then you'll see actually a little bit of red at sunset here coming up. Let that go for just a minute. We're getting close. But you can see the dark is when a really dark cloud came. Okay, so we're hitting towards sunset. You see the sun coming into the image. But it's not like a regular sun. So see how, okay, now you see sunset. But instead of sunset, being what you think, it's kind of like, and then now it's dusk, and now it's night.
So this is a vertical day strip?
Yes. All right. So we've seen time on the x-axis. What if we make time into a tunnel? So I don't have the code, but I'm going to explain how I did this. Okay. So if you think of each image three-dimensionally, it's kind of like a Tower of Hanoi. At the bottom image is, say, midnight, and then it's midnight plus 1, which is a little bit smaller, and then midnight plus 2, which is a little smaller circle, and a little smaller circle, and a little smaller circle, until, midnight plus 100 or whatever at the very top. And I used, what's that? I created a Mayan calendar right there, yeah.
Concentric cropping circles?
Uh-huh. And so I used Pillow. Pillow has a way to do a mask. And so basically the midnight or the first image is the whole image. And then I have a little mask that's a circle that's just a little bit smaller. And then I just paste it onto the existing image. And then a little smaller, a little smaller, a little smaller. So we're going to actually watch this in a movie.
I got your monetization scheme. Oh my god. Yeah.
Oops. Okay, now we're going into night. And then morning again. And that's it, yeah, there you go. So I'll do that one more time. Now it's night. All right. So now we've used a little bit of time. What if we use all the days? What if instead of an image being a whole part of it, what if each image was just a single pixel? And each row of an image was a day, and each column was one image. And I'm going to go quickly because I think I'm starting to run out a little bit of time. So basically the Y is, you can see Y is days, X is an individual image. And then I basically paste the pixel in an image using Pillow, and then I save it, and then I resize it to a standard. Because what you'll get is, you'll get an image that's 8,640 pixels wide, and however many, 400 days, 500 days, 700 days. So this is what you get. So you can really see time in a different way. You can see the bulge area is summer, the little area is winter, and you can see that it's actually asymmetrical, so that the earliest or the latest sunrise does not correspond to the earliest sunset. And you can see more blue on the left-hand side and more white on the right-hand side because, morning versus when the sun's actually in the image, it kind of brightens the thing. And you can really see that if I use max color. Now, max color is really interesting because you see some really kind of crazy patterns. If you look at the scan lines, it looks like you see these white scan lines that kind of, there's about maybe 20 of them. That's actually the moon. So this is about maybe, 20 months worth of images. And so that's the moon. then you notice there's like this kind of 45-degree brightness that goes off on the left and then comes in right here. That is Jupiter. And in fact, that little hook right there on the right-hand side, about a quarter of the way down, that little hook right there is Venus. And you can see there's a lot more gray being the max color in the wintertime than the summertime, and that primarily has to do with the fact that in the wintertime there's often more low clouds, and this points to a location that there's a street lamp, and so the street lamp is getting illuminated by, the clouds are getting illuminated by the street lamp. All right, so we're not done yet. What if we put videos of each day into a mosaic? Sun synchronized the time so we can actually see sunset at exactly the same time per day, but instead of each pixel being a day, we're going to have a group of images, only smaller. So we're going to represent 400 days in a single image. So basically the rows, we're going to have some number of rows, some number of columns, and we're going to iterate through time, the same time each day, and then we're going to crop, we're going to take this image and we're going to put it in its row and column, and what it looks like is this. So this is the same time until sunset for 400 days, 20 by 20. So we need to make a video out of that. Some of them, like the sunset video, took hours because it's 400 images that it has to paste in each frame, and it's 24 frames per second. So this is what it looks like. You can see the cloudy days versus the sunny days. You can see the direction of the clouds. Oftentimes they're coming into the frame or closer because in general clouds go from west to east, but you can see that there's a lot of variation. Now you're going to see as the sun comes in the frame, it's going to look like it doesn't match up anymore, the optical illusion. It looks like things are kind of shifting a little bit. That's because you can actually see how the sun, you can actually see again the progression of the sun throughout the year by seeing the curves, as you go from top to bottom on a single column. You're going to see some static looking things in the middle. That's where camera one broke. It didn't actually break. It just started making these funky little scan lines. Then as we hit sunset, you're going to see the few days that have really brilliant sunsets. Like in the top left there, you see a really brilliant sunset. And you can also see that even though this is sunset synchronized, sometimes there's enough scattering in the atmosphere that it stays lighter longer. You're going to see some lightning too here in a minute. Right there, right there. So on days where there's more scattering of the sunlight, it'll take a lot longer for it to get dark.
More scattering due to
particles, yeah, and clouds, things like that. All right. So, you think we're done? No, we're not. Let's get computer vision in this, right? Let's start recognizing things. So I'm going to give you a simple example. Let's find faces in the clouds, because we all wanted to do that, right? So let's take PySimpleCV. It gives you a pretty much one-line thing called find har features, and someone that's much smarter than me can explain how that happens. But basically, you just do this, and it finds faces in the clouds. And for every face that it finds, I crop it out and save it. How many faces do you see?
Yeah, that with the bottom right corner is the best. Wow. I don't know, that one right there. You wanted the eye.
So there's a couple freaky ones in there, I think. They're like, they look like ghosts. That's a good question. Yeah, I don't think it did. So there you go. So what I wanted to say is, open source makes it possible. These are all the different technologies I used to put this all together. Most of them are Python, but I used OpenSSH, I used Bash, gphoto2, and Linux, Postgres, RabbitMQ. And the thing I have really discovered in doing this project is that with Python, rarely is it the case that the tools lag my imagination. Most of these things were at most 10, 20 lines of code. It was just, I had the idea and I thought, how can I do this, right? And I never had a problem saying, well, I don't know how to do this. There's no way to do this. Everything that I've thought of doing, it's been easy with Python. So that's my little plug for Python. All right, if you have any questions, I think we do have a few minutes for questions, Jason. If you want, please email me. Look at my code. Again, I tell you it's in bad shape right now, but I'm working on it. So thank you so much.
So did your interest in weather and astronomy happen before this project? Is that what made you create the project, or is it something you got interested in after you had all this massively cool data?
So in my baby book, my mom wrote when I was 5 years old that I was interested in dinosaurs, weather, and I think it was space or something, yeah. But yeah, so I've always been interested in the weather. I've always been interested in the sky and just seeing how things change, nature. So I've always had that interest. And in fact, my business that I currently have that uses Python is about weather forecasts. And I created the first version of that application just to satisfy a personal question that I had, which was, is there really any difference between the weather forecast between AccuWeather, the Weather Channel, and the National Weather Service? And it turns out there is. And it turns out that some forecasts are better than others. So yeah, so I've always been interested, but this has really helped me even deepen that interest.
So dinosaur talk next year.
Yes.
Anybody else?
Yeah, so I presume you have the Python code on there. Where is the data? Do you distribute that through like a torrent or anything? Do you consider that your own, you want to keep that for yourself, or would you ever consider selling that as your way to make profit?
I will make a copy of it to anyone who gives me a 6 terabyte hard drive. I have not torrented it yet, but that's actually not a bad idea. And in fact, I've given pieces of it to people that have been interested. So if anyone is interested in the raw data, the raw images, all 6 million of them, seriously, just give me a hard drive and I'll give it right back to you.
How many art museums are you going to be in?
0 right now, but no,
That could be your next profit.
that's a good idea. Thank you.
Yeah, I saw you give this talk, I think it was 2 years ago. It's really cool to see how it's evolved.
Oh, thank you.
You mentioned for a little bit of time you were doing multiple cameras. What was kind of like the pitfall?
Okay, so it was just experimental. And one of the things was just the bandwidth required on the USB. Like I couldn't get more than one camera to actually work because, when you pull down an image, it's coming over USB. So that was one thing. The other thing is that I only have just a window, right? So I really couldn't do 360 unless I wanted to make an enclosure, which then means you have to keep it cool, which means you have to put it outside, which means it needs to be weatherproof, which means you have to run cables into the house, which means drilling. And that was way too much for my mechanical capabilities. So, so what I found was just using a wide-angle lens gave me enough stuff to play with. So, yeah. I think there's a question up here.
How did you find the bird picture? with the 3 birds?
So, okay, so this is a really interesting story. For a little while when I was working from home, I had a monitor and I had a little script that pulled off an image once per minute. So it wasn't even every 10 seconds, it was once per minute, and displayed it on my background. And I kept one monitor just on the background. And I was working and I just happened to look over. I mean, seriously, I just happened to look over and I said, oh my God, that's really cool. And I copied it out. So it was just total serendipity.
So it was pulling a random picture out, or from
Just
the
once a
past
minute. Yeah, just once a minute it would refresh the background on my Linux machine.
So did it happen in the past minute when you saw it? Is that what that means?
Yeah.
Okay.
Yeah,
So it was right after
Yep,
it happened and
yep,
it popped up.
yeah.
And you saw it. So after all the algorithms and everything, one of the coolest pictures was just totally serendipitous.
Total serendipity.
awesome.
Yeah.
No, they're both cool.
This is really cool. Have you ever considered doing something similar with sound to integrate that into the video?
Yes. So just real quick here. This will be my talk next year, maybe. So there's 2 things that I've thought of. One is taking data and turning into sound. So we have visualization, but there's not been a lot on sonification, which is taking data and turning into sound. So one of the things I did was actually take the file sizes of each image and turning them into a sound file. And you can actually hear when the camera goes bad, right? Because the file size has changed. And then the second thing I thought of was, this wasn't for this time lapse specifically, but what I wanted to do was take temperature data, which varies up and down over the course of a day and over the course of a year, and turning it into music.
Yeah. I was thinking it would be cool to do some of the layering stuff that you did to, like, get from a musical perspective, like what the sound would look like if you did those different types of, like, angular looks, like what the sound would look like if you did different slices.
That would be cool, yeah.
Yeah.
Yeah. Yeah, so that's a great idea, yeah.
Cool.
Thank you.
Have you ever thought about doing any sort of trending with your data? For instance, I'm just looking at this thinking maybe you look down a pixel and see what that sort of idea looks like.
I haven't done anything with it, but that's a great idea. Like, yeah, you could look at, like you're thinking maybe how blue the sky is over time, things like that, or is that what you're thinking about? Or
Yeah, just, some sort of trend of,
Yeah.
You can look at night and see how that varies, and maybe there's something in there you could see. Because you did change your axes of X and Y, but maybe if you just look down a pixel.
Oh, that's a great idea, yeah. No, I like that idea, yeah.
All right, thanks.
Yeah, thank you. All right, any more questions?
So you briefly mentioned that with the sound that you could detect if the camera was going bad. Do you have a way that you're detecting that now when it goes bad? Or is that you just spot it when it happens?
Right now I just spot it, but I keep track of like the maximum file size per day, and at least how this camera failed, the last 2 cameras have failed, the file size gets really big. And so if I know that the file size has gotten really big, I know that the camera's failed. All right, I think, are we out of time? Or do we have time for one more? Okay, there's one up here, I think.
I want you to write out like a tutorial so that somebody in a completely different latitude and longitude could set up a camera, and then somehow people all over the world are just putting this data, like he said, on a torrent, and then you make even weirder stuff where it's like X and Y is like latitude and longitude, but it's sunlight. And second
That's a
of
great
all,
idea.
yeah, and then second of all, like, is there science applications of using this to count bird populations?
That's actually a really good idea. Like, one thing I thought of was using the computer vision to identify birds. And then once you can identify them, you can count them. And once you can count them, you can trend them. And to see, like, when birds peak and when they decline, and see year to year, you could see. No, that's a great idea. That is a really... Yeah, so she said you can also compare flight and migratory patterns year to year. No, that's a great idea.
And then I want a to-do so I
So a tutorial for your kids, yeah, how to set it up. Yep. Yep.
That was one of my questions.
Okay.
Like the hardware interface. Like I was like, because I've always wanted to toy with Raspberry Pi, but the community where I live is really, really small, and so
Okay.
there isn't a lot of stuff that I've found, and I'm kind of lazy. Like I want to go face to face first, and then and then
Right.
and then talk to people versus like trying to find out about it online. And so those were some of the questions I had in the beginning of your talk about like how to do the setup and like just
Okay.
interfacing your Raspberry Pi with just a regular digital camera.
Okay,
And
so,
also
so
some
like
of-
a tutorial that actually just walks through the whole setup.
Yeah, and
Okay,
some of the
yeah.
watchouts too, so I don't set up my really, really nice digital camera and then like it fails. It's like, oh, don't use your like
Okay,
your
so
DSLR.
so I've cornered the market on Canon A510s on eBay. I've got like 20 of them, and they're like 10. I get them for I look for a low price, like $10 a piece, and so I've got cameras out for the next 20 years.
I was wondering if you've actually sunk this up with any actual weather data.
I have not, but that is a great idea, and you could actually then use that, like say you want to look at an image that is more humid, like the humid ones, to see how the sky looks versus non-humid days and different things like that.
Well, I was just thinking about, like they were saying with setting up all over the country or whatever, is that like there's all these like pressure net, which is like crowdsourcing
Yeah.
weather or information. And then there's also like all of those like little air sensors that you can buy for like $20 or whatever and sync up. Like you could do a lot with that, and
That's a great idea.
Like so.
Yeah, that's a great idea. So here's a thought that I had for version 4 was actually getting a weather station like a Davis, Vantage View or something like that, and they have basically headless USB interfaces that you can plug in, pull the data off in real time at the location of the camera, and then integrate that into either the EXIF data or into the database. That's a great idea. All right, I think that's it. Feel free to contact me, and I'll definitely think about doing a setup tutorial at some point.
Yeah, let's put some in Australia.
Yeah. Thanks. Thank you.